Hey there, this is Mr. Alexander. Today I want to talk to you about Anova, which is analysis of variance. And in Anova, what we're doing is we're trying to test to see if group means are equal. So, the null hypothesis for Anova is always the same thing. The group means are equal. So you could write it as the mean of salon 1 is equal to the mean of salon 2 is equal to the mean of salon 3. That's the null hypothesis every single time. You might have more means because there are more groups, but that's the basic idea there. Now, what are we talking about when we're talking about means? Well, it says a sample of 4 randomly selected women at each salon recorded how long their manicure lasted in days. Is there a significant difference between the 3 salons? So this is the mean number of days that the manicure lasted. Now, the alternative hypothesis is at least one group is different. Now, to answer these questions, we usually need to know some things. We need to know the standard deviation, we need to know the mean, we need to know the group mean, the whole mean, and we can get that by going to stat edit here in the calculator and typing in the data. So salon 1 is 27, 24, 29, and 26. Salon 2 in list 2 is 23 days, 27 days, 21 days, and 12 days. And in list 3, we've got 17 days, 13 days, 12 days, 19 days. So I've gone stat edit, I've typed in the data. To get the mean for each of these groups, I can do stat calc 1 on list 1. The mean for this one is 26.5. And the standard deviation for this group is 2.08, like that. Now I want to do the same thing, so there's your mean and your standard deviation. I want to do the same thing, but now I want to do it on list 2. So second 2 gives me list 2. The mean of the second group here is 20.75. And the standard deviation for the second group is 6.34. Stat calc 1 on list 3 will give me 15.25 for the mean of this group and 3.30 for the standard deviation of this group here. The last thing I need to know is the grand mean, or the mean of all 12 of these. Grand mean. And I think the easiest way to get that is to just go back and type all 12 values into list 1. So without grouping them. So I've still got the 27, 24, 29, 26, but now I'm going to put in the 23, 27, 21, 12, 17, 13, 12, and 19 into list 1 here. Do stat calc 1 on list 1. The grand total, the grand mean is 20.83. And now, to do Anova, we need to know 3 things in order to fill in the source table here. We need to know the total sums of squares, the between groups, and the within groups. And we've got some fancy formulas for that. Let me just show them to you on the formula chart and zoom in so I can scare you with them. We can do, to get the sum of squares total, it's the total of y squares, the sum of the y squares minus the sum of the y squared divided by n, which is 12 in this case, the total. And then we've got some fancy business here where we need to know the group means and the group means and the grand mean as well. We can do all those calculations, and I could show you. It's going to take me longer than this 15-minute video. So what the purpose of this video is just show you how what the calculator handled most of that for you. Let's start with the sums of squares between, which was this formula here, which is the group mean, the sum of the group means times, the sum of the group sample size times the group mean minus the grand mean squared. Since we have 3 groups, we'd have to do that 3 times. I'm not real interested in doing that. What we can do is let the calculator handle it for us, and we can do that by going back here to stat edit, going back with my original data, 27, 24, 29, 26, that's group 1, 23 days, 27 days, 21, 12 days, 17, 13, 12, and 19. I've got my 3 groups like this now. If I go to stat, go to tests, at the bottom here, stat test H is Anova. If you just specify those 3 groups, L1, L2, and L3, it's going to do a lot of calculations for us. Right here when it says factor, in OnRamps, we use the word between. The sum of the square variance is between, and it's right here, that sum of squares between. Sum of squares between is this 253.17. So where you see the word factor, that's going to mean between. Now it also says degrees of freedom equals 2, which makes good sense because that 2 represents the number of groups minus 1. We have 3 groups. To get to the sum squares between, the degrees of freedom for the sum squared between is always the number of groups minus 1. In this case it's 2. 3 minus 1 is 2. If I scroll down a little bit, where it says error, we call the error in OnRamps, we call that between, or sorry, within. So the sums of squares within is going to be this 166.5. Now the total sums of squares at the top here is just us adding those together. Oh wait, I'm sorry, I forgot to write down the degrees of freedom for that one, which is 9. Degrees of freedom for this one is 9, and I'll explain why that makes sense in just a second here. The sums of squares total is simply the sums of squares between plus the sums of squares within. So it's that 253.17 plus that 166.5. So the total 17 plus 166.5 is 419.67. With this information, I actually have enough information to conduct the Anova test because I can use the source table now. The between groups sums of squares was 253.17. Within groups is 166.5, and the total, when you add them together, is 419.67. Now, the degrees of freedom between groups is always the number of groups minus 1. So 3 minus 1 is 2. For the total, the degrees of freedom is always the total sample size minus 1. So I had 12 things up here, 12 individual people who told me how long their manicure lasts. 12 minus 1 is 11. These have to add up. So 2 plus 9 equals 11. So I said earlier that this degrees of freedom within it being 9, that makes sense. This is why, because 2 plus 9 has to equal 11. Now this mean square, to get that, we simply have to divide straight across here. I need to do this 253.17 divided by 2, which is 126.585. And the mean square within groups is going to be 166.5 divided by 9, which is 18.5. Now, can we use the calculator to confirm that? Yes, I can. If I go back to stat, go over to test and Anova, list 1, list 2, comma, list 3, check out the mean square for the factor, which is between for us, 126.583, that's what I got right there. And for the error, or the within groups for us, 18.5, just like I calculated. Now to get that F statistic, we're going to divide these two things. We're going to say, okay, to get the F statistic, we're going to simply divide 126.583 divided by 18.5. That's going to give me 6.84 for my F statistic. Can I confirm that on the calculator? Yeah, sure. check out the F statistic at the top here, 6.84, just like I calculated right there. Now it's going to give me a p-value, 0.0156. The only way to get that p-value normally is to compare it to the critical value, and we could say less than or greater than 0.05, but since the calculator gave it to me, I'm just going to write it right up here, 156. The F critical, the calculator's not going to give you that, but you can get the F critical from the table here. Here's the F table, very last one. You've got your degrees of freedom in the numerator, which we said was 2. And you've got your degrees of freedom in the denominator, which we said is 9. Our F critical is 4.257. 4.257. So, what that means is, if I was to draw a rough F graph here, here's my F, and here is my F critical, 4.257. Anything to the right of that is my rejection region. Well, where's my F stat? It's right here at 6.84, clearly in the rejection region. So normally we'd say, oh, since it's in the rejection region, that means the p is less than 0.05. And I can confirm that by looking at the p-value that my calculator gave me. It's definitely less than 0.05. So what does it all mean then? I'm rejecting. What does that mean? That means that at least one of these groups has a different mean than another one. So at this point, all we can really say is, all right, reject the null hypothesis. At least one group is different than the others. And that's it. That's the whole Anova test. Now there's another step here where you ask yourself the question, okay, well if at least one group is different, then which group is it? And we've got some other math we can do for that. We'll save that for another video though. So thanks for watching. That's Anova in a nutshell. We'll see you next time.